Welcome to your Get That Nugget for GCSE Maths. Today we'll be concentrating on giving you a framework to answer questions about the product rule. This session is to complement your lessons with your teachers and is not to replace them in any way. Okay, so today we're going to look at the product rule, which is a nice way of figuring out combinations of things or total number of combinations of things. However, before we do that, let's think about example 1 and think about how we could work this out. So there are 3 girls and 2 boys running for head student. 1 girl and 1 boy will be selected. How many possible combinations are there for possible head students? So if we think about the girls to start with, say we've got girl A, girl B and girl C. Now we're picking 1 girl and 1 boy. So out of these 3 girls, if we say boy A, for example, they could all be paired with boy A, okay? So we've got 2 boys. So girl A could be paired with boy A, girl B could be paired with boy A, and girl C could be paired with boy A, okay? Now, if I write these out again, because we've got girls A, B and C, all of them could also be paired with boy B, okay? So all of them could be paired with boy B. So girl A could be with B, B could be with B, and girl C could be with B, okay? So altogether here, we have got 6 possible combinations, okay? Now, the product rule ultimately is a way of us figuring this out without having to do what we've just done there. When we've got 3 girls, 2 boys, it's actually really, really easy for us to do, like we've just seen here. But the product rule ultimately is a much quicker way for us to do that. And the way we do it really is by multiplying our number of girls we've got, which is 3, by the number of boys, which is 2, which gets us 6. We've got 6 possible combinations of head students, okay? So example number 1 really was just there for us to see the possible combinations and to show us really that the product rule is just a much quicker way of us being able to do that. So let's have a look at example number 2 then. So example number 2, there are 14 girls and 16 boys in a class. 1 boy and 1 girl will be chosen for the student council. How many combinations for choosing a boy and a girl are there? So again, if we were to be doing this like we did on example 1 and we were to go through all of the girls, we'd have girl A and boy A, girl B, boy A, and it would go on for a really long time. It would take us a really long time to write out all these combinations because we've got 14 girls and 16 boys. So the product rule ultimately just helps us to figure this out really, really quickly. So we're choosing 1 boy and 1 girl. So we have got 14 girls and 16 boys. So we do 14 multiplied by 16, and that's all we need to do, okay? 14 times by 16 gets us 224. So that tells us that there are 224 ways of choosing a boy and a girl from this 14 girls and 16 boys in the class. Now, if you imagine if we had written out all of those combinations, 224 different combinations would have taken us a really long time. Chances are we'd have probably missed one as well. And so the product rule is just really helpful to just have a quick way of figuring that out. Okay, example number 3 then. A restaurant has 5 starters, 7 main courses and 4 desserts. Work out the total number of different options for all 3 courses. So this time then, we're going to do 5 because that's the number of starters we've got, multiplied by 7 because that's the number of main courses we've got, and then we're going to multiply that by 4 because that's the number of desserts we've got, okay? 5 times by 7 times by 4 gets us 140. So there are 140 ways of picking a starter, a main and a dessert. Again, if we were to write all of these combinations down, that would take us a really, really long time, okay? So in that restaurant, there is 140 different options for a 3-course meal. Okay, let's have a look at example number 4 then. Tom is choosing a code for his padlock. The lock is a 3-digit number. Tom wants the first digit to be above 5, and he wants the last digit to be a multiple of 3. Work out the total number of possible combinations for Tom's padlock. Now, this one requires a little bit more problem solving from us. So what we're going to do first and foremost is we're going to think about our first digit of the padlock, okay? So we need to figure out the total number of combinations, but first and foremost, we need to figure out how many numbers we could have for our first digit. Now, Tom wants the first digit to be above 5. Now on a padlock, you're going to have the numbers 0 to 9. They are 1 digit. We're not going to have anything above 10. Okay. So he wants it to be above 5. Now this is not above 5 and including 5. It just says above 5. So our total possible options we've got are 6. He could have 6, 7, 8 or 9. Okay. So the first digit could be 6, 7, 8, or 9, okay? The digits are 1 digit, so it can't be a 10. So there's 4 possible options for our first digit, okay? It could be 6, 7, 8, or 9. Now, if we then look at the second digit, okay, now it says here that Tom wants the last digit to be a multiple of 3, but the second digit it doesn't give us any information about. So our second digit could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, okay? So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible options for our second digit because Tom doesn't have a requirement for that second digit. Now, if we then look at the third digit, okay, now it says here, Tom wants the last digit to be a multiple of 3. So what we then need to do is figure out the possible numbers that are multiples of 3. So from this list, and it's this list here because this is the total digits, we've got 3, 6, and 9. All of those are multiples of 3. And so my third digit, I have got 3 options. Now, what we're then trying to do is work out the total number of possible combinations for Tom's padlock. So all we're then going to do is 4 times by 10 times by 3, okay? 4 options for our first digit, 10 options for our second digit, and 3 options for our third digit. Now, 4 times by 10 gets me 40, times that by 3 gets me 120, okay? So there's 120 possible combinations that Tom could have. Okay, example number 5 then. There are 8 different sandwiches and X different drinks in a supermarket. Annie says that there is 116 different ways of choosing a sandwich and a drink. Could Annie be correct? Now, if we think about our product rule would tell us that if I was to do 8 multiplied by X, okay, that's going to tell me the potential number of options that we're going to have. Our issue here, however, is that we don't know what X is. We don't know how many different drinks there are in a supermarket. Now, Annie thinks there could be 116 different ways of choosing a sandwich. Could she be correct? Now, the way we're going to do this is we're going to work backwards. And so what we're going to do is 116 divided by 8, okay? Now, this kind of question could be on a calculator, could be on a non-calculator. We'll do non-calculator just in case. So 116 divided by 8. 8's going to 1 0 times, carry the 1 over. 8's going to 11 once, okay? Remainder 3. Now, 8's go into 36. Now, 8's go into 36 4 times, okay? 4 8s make 32, which means we've got 4 left over. Now, normally if I was doing division, what I would do is I would say 0.0, okay? And I would carry that 4 over, okay? Which means then I would do 14, 8 divided by 40 gets me 5. So 14.5. Now, if Annie is correct, what that is telling me is that it must be 14.5 different drinks because I would have to do 8 times 14.5 to get 116. Now, you can't have half a drink option. That's not a thing that's possible, which means no, Annie is not correct, okay? It must be a whole number because that's how many different drinks options we'd had. If, for example, Annie was saying there's 80 different ways of choosing a sandwich and a drink, Annie could be correct there because 8 times 10 would get us 80, which means there could be 10 different drinks options. In this case, however, 116 divided by 8 gets us 14.5, and you can't have 0.5 of a drink. Okay. There's 2 examples here for you to try. So one, and these questions, when you get them in exams, are all worded very similar. Ways of choosing a starter and a main. And Shauna says there's 108 different ways of choosing a coffee and a cake. A cafe sells 9 different cakes. Could Shauna be correct?